Good morning, good afternoon, and good night. This is our LB 273 Lab Report 1 with Ethan Stav and Caitlin Smiles on diffusion. The first thing that will be talked about in our presentation is our main problem. So what we are discussing is the motion of particles in diffusion. So the issue is, how do different solutions impact the rate of diffusion of particles? We have two hypotheses in this experiment, the null and the alternative. The null hypothesis is that there is no difference in velocities as particles travel through solutions with different sized particles inside them. The alternative hypothesis is the beads will move at a faster velocity in water than soap, since soap molecules will have a higher internal friction than water molecules do.
So this is essentially the model of our hypothesis. We're thinking that the green balls on the left would represent the polystyrene beads in the soapy water, moving slower, whereas the white balls on the right would indicate the polystyrene beads in just the plain water, moving faster. However, our hypothesis didn't seem to quite hold true, as the polystyrene beads move faster in our soapy water than in water solution.
Say what?
The goal in this experiment was to find the average velocity of the polystyrene beads in two different solutions that were used, which was water and soap. The controlled variable in this experiment was the size of the beads. We found that the mass equals 5.2 times 10 to the negative 12 grams. This was found by us finding the density of the beads and knowing that the diameter was 5 micrograms. The independent variable in this experiment is the solutions, which is water and soap. The dependent variables is the rate at which the particles will move. In this experiment, we had three different trials per solution and tracked the positions over time using the microscope and computer.
So using Tracker, we are able to find the average velocity of the beads as they traveled through water and as they traveled through soap. As you can see, we found that the average velocity of the beads in the water traveled much slower than the beads in the soap. We decided to calculate the momentum of the beads because we wanted to show that since our polystyrene beads were the same size in both solutions, that our momentum results would be consistent with our velocity results. This holds true in that our polystyrene beads in the soap solution had a higher momentum than those in the water. Alright, so let's break this down. So after analyzing our results, we found two possible explanations for our results. First, the soap could actually make the beads move faster and we could reject our hypothesis and do some more testing. Or, two, there may have been some human error. We'll talk about that soon. So a plausible explanation for the polystyrene beads moving faster in the soapy water solution than the water solution is density. Density explains the compactness of a solution. The higher the density, the more compact, the less movement available for the particles inside the solution. The less dense a solution, the more room for the particles to move around because it's less compact. So even though those models were quite exaggerated and the density of soapy water isn't all that different from the density of water, we can still conclude that the density of soapy water is less than the density of water, and so that the compactness of soapy water would be less than the density of water, and so there'd be more room for the polystyrene beads to move about freely with less collisions, which could cause a higher velocity. Alright, so here's where we come clean. There definitely was some error in this experiment because our soap trials weren't great models of diffusion. As we had some time constraints, we collected all the data that we could, and most of our soap trials, our particles were moving linearly, as you can see in the bottom right-hand corner graph. 3 out of our 4 trials of soap looked like this, which shows that our data probably isn't the best, and so we need to do some more testing to see if we could accept or reject our alternative hypothesis. So originally what we thought would happen was that the polystyrene beads in the soapy water solution would move slower than that of the ones in just the water solution. We used this because of Newton's first law, stating that an object will remain at rest or in uniform motion in a straight line unless acted upon by external force. In this case, that external force being the water or soap molecules in which the beads are in. Originally, what we had believed was that because the soap molecules were such bigger, heavier molecules, that they would be moving slower and they would take up more space in solution. So because the soap molecules were bigger and heavier, we thought that there would be a higher internal friction of the solution, meaning that there was a higher force that resisted the movement between particles of the material because there was more availability for collisions since soap molecules were bigger and they had more surface area to rub up against one another. And because internal friction is a force that resists movements between particles of a material, we thought the velocity of the polystyrene beads would be slower than that of the soapy water solution. So overall, in order to make solid conclusions on this experiment, I think we need to run more tests.